This is lesson 10-3, operations with radicals. So first we'll deal with addition and subtraction and the rules that we need to follow with addition and subtraction. The first thing you want to do is to simplify all of your radicals. All radicals must be simplified before proceeding with addition and subtraction. At this point, you're only allowed to continue if your radicands are the same. Now, keep in mind what radicands are. Your radicands are the number that's underneath the radical. So up on the top right here, I'm just going to write a radical, and we'll just say radical x. So remember that this is considered the radicand. And if we had a number in here, this would be called the index. Now remember, if there is no number represented in the index, then it's assumed that it will be a 2 in that spot, a square root. At that point, if you have the same radicands, you can add or subtract the coefficients. You leave the radicands alone. If you notice, the process is extremely similar to how we would add fractions. We leave the denominators alone while adding the numerators when we do fractions. In this case, we are adding the coefficients and leaving the radicands alone when we do radicals. Here's a guided example for you. We have 3 radical 2 plus radical 8. At first, I sit there and I check to see that I have simplification on both. Radical 2 cannot be simplified at all. Radical 8, however, can. We can simplify that into radical 4 and radical 2. Now, radical 4 automatically becomes a 2 when it comes out because, again, 4 is a perfect square. And again, remember what we're looking for when we simplify radicals. We are looking for the biggest possible perfect square factor of the radicand. So radical 8 simplifies to 2 radical 2. We're just going to bring this down. So we have 3 radical 2 plus 2 radical 2. And I'm going to add 3 and 2 to get 5. And I leave radical 2 alone, and my answer is 5 radical 2. Here's some examples for you to try. Pause the video at this point to give yourself a chance to try them on your own. So on the left side, again, when we have a combination of a variable and a number, we want to break those radicals up to start. And so we have radical 12 and radical a. Now radical 12 can be simplified with radical 4 and radical 3. Radical 4 becomes a 2. Radical 3 cannot be simplified. Radical a can also not be simplified, so we're going to combine by multiplication the 2 radicands. So radical 12a simplified becomes 2 radical 3a. And radical 3a cannot be simplified because, again, radical 3 can't be simplified and radical a can't be simplified. So this part is going to come all the way down. And we're going to add 2 and 3 to get 5. So we have 5 radical 3a for the left side. For the right side, we are going to split up the radical 2 and the radical a to the third. Radical 2 cannot be simplified, but radical a to the third can. So we have a squared and a. Remember our rules for simplifying variables under radicals. We want to look for if it has an even power, we can just take it out immediately. If it has an odd power, we're going to split it up into the variable itself and one less than the original exponents. That's why I have a squared and a. Radical a squared comes out as a. I'm going to combine the radical 2 and the radical a into one radical. So that gives me a radical 2a. Now I'll come over to the other one, and we have radical 8 and radical a. Radical 8 can be simplified into radical 4 and radical 2. Radical 4 becomes a 2. So what we have here is minus comes straight down, and we have 2 radical 2a. And so now we're going to subtract the coefficients, and we have unlike terms as coefficients. So here's how we're going to write this. Watch this now. A minus 2 in parentheses, because again, we can't subtract a and 2. We don't know what a is. And then we leave radical 2a. That's a little fancy. It's a little bit above. Okay, shouldn't hurt that much. Okay, just keep in mind again that a and 2 are not like terms, and you'll be just fine with that. The rules for multiplication and division are the opposite of what we had for addition and subtraction. We're actually going to multiply and divide first, not simplify first. We're going to multiply and divide the coefficients, and then multiply or divide, depending on the situation, the radicands. And then we will simplify the radical at the end. Let's take a look at an example here. We have 4 radical 2 times 5 radical 3. So I'm multiplying this time. I'm going to multiply the coefficients first. That's 4 and 5. That gives me 20. And radical 2 times radical 3 gives me radical 6. And radical 6 cannot be simplified, so that just ends up being my final answer for that example. Here's some examples for you to try. Pause the video at this point to give yourself a chance to try them on your own. One thing that's critical with these examples is to remember that if there's no coefficient present, we can always put a 1 in that spot. So for the left side with multiplication, we're going to multiply first. And we have 1 times 3, which will give me 3. And then we have radical 12a times radical 3a. We're going to multiply the numbers first. That gives me 36. A times a gives me a squared. Now we want to simplify these. We're going to break it up first into the number and the variable. And radical 36 is a perfect square. That can immediately simplify to 6. Radical a squared is also a perfect square. That simplifies immediately to a. So now we have everything on the outside, and we're going to multiply everything together. 3 and the 6 and the a, and that gives me 18a. For the right side, again, we can stick a 1 there if that bothers us. 1 divided by 2 is 0.5. I'm actually going to leave it as 1/2. For me, that makes it easier. If you want to leave it as a decimal and make it 0.5, you're more than welcome to do that. Then we're going to divide our radicands, and then what we have here is 8 divided by 2 being 4, and then remembering our rules of exponents, a to the third divided by a to the first, we subtract exponents. That gives me a squared. Now we'll simplify the radical, breaking it up. We have radical 4 and radical a squared. Radical 4 is a perfect square. It simplifies to 2. And radical a squared simplifies to a. So now again, we're going to multiply 1/2, 2, and a. And that gives me a final answer of simply just a. When we multiply 1/2 by 2, we get 1. So we just have a as our final answer. And that's important that if you were writing it on an open-end response question, you certainly could put 1a. But if it was a multiple choice question, you would only see the answer being A. If you're having any issues with any portion of this lesson, please make sure you are emailing me or consulting me in class.